Hello, my name is Dennis, and I'm a software engineer at Volt. And I know no one here tried Volt, but Volt is a European leading food tech startup. And for those who don't know that, it's just a simple food delivery service. And as you never tried it, it's simple. You have an application. And you think, OK, I would like to have a burger from that restaurant, or I would like to have some steak from other restaurants. So you click on it, you choose where to deliver it, slide to confirm, and in 20 to 40 minutes, your food magically arrives on your door. That's simple. On the back end, some magical unicorns start jumping over our servers and finding the best solution for your problem, like finding the best courier partner, estimating how long it will take for your meal to be prepared, how long it will take for your meal to be delivered. And of course, a lot of those calculations involve map. And yes, that's not a secret. We use OpenStreetMap. You're right. It rocks. We use OpenStreetMap. And the problem with OpenStreetMap is that OpenStreetMap is a database of all the features of the planet, somehow connected. So it may be below the planet's surface, but still. And the planet's big. For example, it takes 3 hours to fly from Helsinki to Belgium. And it's still in Europe. And if you'd like to fly to Japan, it will be 12 hours, 14 hours, I don't know. So the planet is big. That means database is also big. It's 1 and 2 terabytes. I checked last week. The XML, uncompressed XML file is 1.2 terabytes. And you usually can't process 1.2 terabytes with ease on your laptop. You have not that enough RAM. You probably don't have even enough disk space. So it's a perfect case for Apache Spark. And that's geospatial. So probably you don't know what is Apache Spark. And Apache Spark is open source, distributed, general purpose, cluster computing framework, lot of buzzwords. Simple words. That's a magical thing. Yeah, I love the word magic. That's a magical thing that allows you to process huge data sets. And it allows you to process huge data sets in RAM, so making it fast. And then I think, like, wait a minute. You have host with 1.2 terabytes in RAM? No, I don't have. I would love to have one, but I don't have one. How Spark does it? That's simple. You have many hosts. You don't have 1.2 terabytes in one host, but you have 100 hosts with 10 gigabytes each, giving you 1 terabyte. And Spark will automatically partition your data set into those hosts and load small parts into each host. So you have a lot of RAM online, but not on every server. And of course, server is not just a RAM, it's also CPU. And usually it's power of CPU with a lot of cores. So you have a lot of cores attached to each of your partition. And it makes processing faster. You can run calculations on each partition in parallel. Can we do it with OpenStreetMap? The first thing that you can try, and I tried it, let's import your data into some database. PostGIS database, MongoDB, Elasticsearch, whatever, doesn't matter. Let's get it into some database. And then let's use Spark connector to load your data from database, while at the same time you can filter your data, because it's database. So you can ask a database, could you please give me everything inside that polygon, or everything near that point, or something like that. And database will do the stuff for you. That's a good side of that approach. The bad side, you have to import your data, and it may take hours. And you need to allocate a lot of space just for database. And every time you update your Planet file, you have to import your Planet file or work with diffs and maintain your diff update infrastructure. So it's painful, especially if you have some one-shot problem. OK, let's try another way. There are some tools in Spark, ready-made tools like Magellan or GeoSpark. And they can read things like shape files. They can read GeoJSON. They can read files in well-known binary format. So you can convert your OpenStreetMap file into one of those formats and tell Magellan to load it. Will it work? Yes, it will. I tried it. It works. Is it good? Well, it's here. So you don't have to write any line of code. But you have to convert. And most of the conversion procedures require, guess what, database. So it's even slower than the first approach. So you still load into database and then exporting. And as you are not reading from database, you're losing all the filtering stuff. Third approach, what if Spark could load this OSM file directly? Will it solve the problem? Probably. Sorry? Yeah, it's compressed, but, well, we have a lot of cores. Let's uncompress it. Can it load it directly and uncompress? Probably yes. But, well, there's no but. It's just a simple way. You just point to the URL, like, dear Spark, please load the planet file from the OSM site, and that's all. Or you can even push down the filters in the Spark, and it will not load the whole file, but partial file. The problem, it wasn't implemented. So I had to implement it. And the first problem was the OSM data. You know, everyone, I hope everyone here knows that OSM consists of nodes, ways, and relations, and only nodes have geometry. And because of that, all the OSM files are conventionally sorted for you. Like you have nodes first, then ways, then relations. And if you read them sequentially, before you hit the first way, you've probably seen all the geometry you need to reconstruct your way. Probably. But let's hope you do that. And because of that, most of the readers, well, actually all the readers I've tried, are single-threaded. And now just imagine you have a huge cluster of, say, 20 hosts, 16 cores each. I don't want to multiply them, but a lot of cores. And they're waiting for a single core, slowly crunching and decompressing your OSM file. A lot of resources are wasted. Can we do it better? Yes. The solution number one, parallel PBF. The PBF reader written in Java 8, so you can use it in your legacy Java application. It supports all the current OSM features and options. It's available under GPL v3, on a GitHub, on a Maven Central, so you can start using it right now. And actually here, this is the whole API of the reader. You just specify what to do if you hit some entity. You see a node, call this function. You see a way, call this function. You don't have a function to call for a way, don't read ways at all. Skip them. Let's do it faster. And is it faster? For example, for Belgium, well, it's 11 seconds. It's not that much. But if you're reading the whole planet, I was comparing the Osmosis built-in reader and parallel PBF on the same host with locally connected SSD drive. The whole planet, you're reading all the entities and checking for all the entities with specific tag. Fix me for no reason. Don't ask me why. That was just an idea. 45 minutes on a single thread. Less than 15 minutes with a lot of threads. I just saved you half an hour of your life. It's worth it. So let's take that parallel PBF and drop it right into Spark. Oh no, it's not working again. And you know why? For Spark, if you just drop that stuff, you have to load all your data first. So now you still have your 20 hosts, and just a single host with all its cores crunches your data, but all the other hosts are waiting. And even worse, you have to load all your data first into your RAM, like 1.2 terabytes. And if you have that amount of RAM on a single host, you probably don't need Spark. But just imagine you, for some reason, have it, and you load it into your RAM, and then you tell Spark, dear Spark, could you please create data frame from that array? And guess what Spark will be doing? It will split it and slowly redistribute over other nodes. So even more slow in the process and transferring all your data over the network. Slowly, I tried it. It would be better if we will have native Spark awesome data source. And now we have it. It's built, of course, on top of parallel PBF. It supports Scala 2.11, Scala 2.12. I will compile it for 2.13 when Spark will be compiled for 2.13 one day. And yes, it's available at GPL v3, on a GitHub, on a Maven Central. And the best thing here, it supports native partitioning. So you just tell your Spark now, dear Spark, could you please load that file? And that file could be anywhere. It can be local file, it could be S3 file, it could be URL, whatever Hadoop file system supports, because internally it's Hadoop file system in Spark. And at the same time, you tell Spark, I would like this file to be split into several partitions, like how many executors you have, or how much RAM do you have, I don't know. It's up to you. And Spark will ignite all the executors. And each executor, each node, at the same time will start reading their own part of your Planet file. Or it's not to be a Planet file, any PDF file. In parallel, fast, and no shuffling anymore, no transferring of data between Spark nodes. And the best thing here, the same test, calculating fixed me tax, on the whole planet takes just 2.5 minutes. We start with 45. Now it's 2.5. And you would think like, OK, come on, Pell, you just dropped 720 cores and telling us, oh, yeah, it's fast. Of course it's fast. You have 720 cores. It should be expensive. Nope. Nope, it's not that expensive. Yeah, running that kind of cluster on Amazon, I tried with Amazon, will cost you probably several hundred euros per day. But for 2.5 minutes, it's 5 euros, if I remember correctly, for something. The coffee here costs more. So it's not that hard. Now you have your data frame in RAM, but it's awesome data frame. So no geometry, just nodes, ways, relations. Hard to work with. And now comes the third part. That's collection of Spark snippets to help you to work with the awesome data. It's really work in progress, so it's heavily unstable. I'm updating it every day, and it's mostly used for my needs. Sorry. Same Scala 2.11 and Scala 2.13, 2.12, sorry, and will be for 2.13, and Spark will be for 2.13. It's available on GitHub. It's not yet on Maven Central because it's really under development right now. And some simple procedures like I would like to limit my data frame to some polygon. I would like to find geometry for some ways. I would like to resolve some multi-polygons. Export to Osmosis database. Actually, I used it just for debugging. It's not that useful. And I even made a simple renderer in a Spark SQL language. That's funny. Well, enough talking. Some short example. The example part was the hardest one. I was thinking like how to show it. And I thought, OK, probably everyone here uses public transportation, at least to get there. And public transportation can be a problem. If you go somewhere, you don't want to go too far away for your stop. Let's calculate public transport coverage by finding all the buildings and all the platforms and finding the nearest platform and then colorizing buildings. Like if it's blue, the platform is right here. And if it's red, the platform is in several kilometers. Here comes the whole code for all that stuff. Like you load map, you do the thing that you shouldn't be never doing. I'm finding for a single entry of a data frame. And Spark is quite bad in finding a single entry. It's much better in processing all the entries, not a single one, but it's good enough for demo. Find locations, get geometry, calculate distance, and mark buildings. The only function skipped here is the colorizing buildings with a distance, because it's actually just a huge table of distance to RGB values. It's not that interesting. That was the whole example. And what we will get now, I calculated for Brussels. And when I got the result, wow, is it really that good? Oh, it's much better on my laptop, actually, than here. But I have a better picture for you. It's near my hotel. You see, almost everywhere you have to walk just several hundred meters. And it's calculated with Spark on this one laptop well, with this laptop it takes more than a couple of minutes, but still, I don't remember, maybe 10 minutes. And yes, it works. It proves it works. So that's not all. I'm going to improve that stuff. And you see the first option here is striking out. While flying to Brussels, it takes 3 hours, I told you. I actually implemented that stuff. You can write parallel PBF, you can write PBF files in multi-threaded manner. Of course, they will be unsorted, so you can process them with typical tools like Osmium, for example. But you can load them back into Spark if you like. For data source, Spark is good in pushing down the filters. Like if you have some options like I'm filtering on some tag, I'm filtering on some type of entity, and so on and so on. Spark can push down and write to data source, and I need to support more predicates. Probably geometry conversion and load, I have to think on that because it will slow down the load. And for the tools, well, I need to better support for all types of relations, well, at least for all types of geometry relations. And probably GraphX support for relations hierarchy or polygons hierarchy for multi-polygons. Definitely, I'm going to implement geometry operations, so convert into VKB, so GeoSpark and Magellan will be able to operate directly and vice versa. That's the thing you can visit. Everything is on GitHub. By Vault, you can contact me on a GitHub or on a mail. It's time to make a photo of this. I'm waiting. Yeah. Okay. And thank you for attending, and it's time for your questions.
Thank you. The first question.
Yes.
You could have gotten also away maybe by converting the protocol buffer format to a Parquet and then using Spark feeding the Parquet friendly format. Of course, I wouldn't have benefited with all the goods of the Spark OS tool, but for a first step, I could have done like that.
So the question was like, I should convert the OSM data to Spark Parquet format and then use it. That's what I'm doing in real life. I use my data source to read it into RAM, filter it, and then write into Parquet format and then processing it. Yeah.
Is there a specific reason why you choose the GPL version license for the OSM data source and the Apache for the tools?
Well, the question was why I choose the GPL version. The real answer is that down below I'm using cross-buy parallel. Oh, sorry, I'm using cross-buy PBF. How it's called? Artifact. Yeah, and it's GPL. So I had no choice.
The lady over there.
Yeah.
I feel like one of the things that prevents me from using, well, if I want to use Spark, but prevents me is I actually don't know any geometry libraries. So when you showed that distance example, did you just write your own UDFs or like pull something in? How did you?
That function above, that's my own UDF that calculates geometry.
But you don't, so like, so if I wanted to like point in Polygon, there's no like geometry library.
I have plans to implement conversion to geometry, so you will be able to use, for example, Magellan or GeoSpark, and at the same time you can write your geometry UDFs using GTS functions, using GTF library. You're very welcome.
Someone else.
Yeah.
So you are comparing as I understood, the purpose of this work, which is really great.
Thank you.
Or assembling for Spark, but as I understood, you did it for the speed, like to make or assembly engine as fast as possible.
Is that all the question?
No.
Okay, go on.
And you're comparing with Osmosis, and Osmosis is like the slowest PBF reader there is. So, and counting tags when done with, for example, Osmium would take like a minute to plan file. It will be much faster and just on a single core, not 700 cores. And building this map would take like a minute with PostgreSQL and QGIS, including loading the project into QGIS. So why did you use Spark?
Because you can do much more with Spark. You can do graphs, you can do reading unlimited stuff.
I can do much more with Osmosis and with QGIS and PostgreSQL.
Okay, so the question was, what in 2 words, what was the use case for it? So why I'm using Spark and why I'm comparing to Osmosis and all the things. So the answer, this software is used internally in Vault for different kind of analysis. So that's a part of an analysis pipeline, which is run on Spark. So I have to put all the data in Spark. That was the first reason. The second reason, it's not for speed. Yeah, that's strange. It's not for speed. Of course, I would love to do it in just several minutes, but it's not for speed. The fastest way, if you need to do it all the time, like you have recurring tasks that you recalculate every several days, would be using Postgres and as you mentioned. But if you need to make some one-shot analysis, like, let me check that theory. You don't want to spend several hours configuring your platform. You don't want to spend several hours installing your PostGIS, well, downloading via Docker, configuring your EC2 host, and so on and so on. You just load it into Spark. That's the main reason. It's mostly for one-shot things. And yes, it's not that fast as a specialized tool, but it's a general tool. So with specialized tool, you can do much faster, but narrower. But you can solve narrower area domain of problems. But with Spark, you can solve almost any problem. Like you mentioned, you can do graph analysis, for example.
Okay, I'm going to cut you off, guys. There's people waiting outside.
Yeah.
And we are just in time. So thank you very much.
Thank you.